Hey, I'm Sasha and welcome back to the fifth and final video for Millie's Flying Fish. This focuses on the module control methods. In parts 1 through 4 we designed and manufactured the physical body, then tested out the servo, communicated with the gyroscopic sensor, and finally converted the gyroscopic sensor data into an accurate rotational position. The aim of this video is to build on the previous parts and implement a PID control system that is able to accurately control the angle of the fish when airflow is provided. First of all, we need to take care of the wiggle from part 2. Reducing the tail weight from 40 grams to just under 17 helped a little, though not quite enough. Before swapping to a large servo, I decided to overvolt the servo to 7 volts. However, this actually increased oscillations further. This is when I developed a new theory. What if increasing the voltage throws the tail harder, but doesn't actually increase the stopping where I want it to bit? Through testing, I found lower voltage reduced oscillations significantly. Due to this, I will run the servo at 3.3 volts. Now that we've fixed that issue, we will move on to implementing the PID control system. First of all, a really quick explanation of what PID control is. PID stands for Proportional Integral Derivative. These each represent different interpretations of the error signal. Proportional error is just proportional. If the angle of the fish is at 10 degrees and the target is 0, the proportional error will be the difference of negative 10 degrees. Using just proportional error can work pretty well, but it can leave a small bias between the target and actual angle. This is where integral error comes in, which adds up the small difference over time again and again until it goes away. Finally, derivative error is the rate of change of the error, or its slope. Derivative error acts as a dampener and can help reduce overshoot. We multiply each of these errors by a gain value, then sum these up to create the output signal. The act of picking these gains is called PID tuning, which we will get to shortly. The program for this section builds on the prior part, where we obtain the rotational position of the fish. Compared to the previous program, we've added some more variables and initialized the servo in the setup loop. The main loop is very similar, as we still need the rotational position data, however a couple new sections have been added at the end. We calculate all 3 PID errors, then combine them with the gain values to get our error signal. We then clamp these values and move the tail to the target position. A quick note on PID tuning. I initially tried using the method shown on screen now that I'm not even going to try and pronounce, but found my servo often produced weird oscillations like the wiggles we saw earlier. I found that even adding a little derivative gain increased these oscillations quite a bit as well. Due to this, I experimented with values that I thought were reasonable and found a Kp of 1 and a Ki of 0.6 with no derivative gain worked fairly well. This means we're actually using a PI controller, not a PID controller. We can now finally get into the tests. We will run 3 tests as follows to show the capabilities of the system. First, we will have the fish hold a 45-degree angle on startup, then after 2 seconds move to negative 10 degrees. Secondly, we will try and hold a steady 15 degrees as we rotate the base for the fish and see if the system is able to adapt. Finally, we will hold a straight angle, but I will change the direction and intensity of the airflow, and also push the fish around a little. Now commencing the first test, we see the fish start up, then quickly move to roughly 45 degrees. After around 2 seconds, we go to negative 10. Next, in test 2, the system starts and moves to 15 degrees. I then pick up the fish and spin the base. As you can see, the fish holds the 15-degree angle. Finally, onto the third test, I'll start by pushing the fish around a little. We can see that the fish always returns to the target straightforward position. Now moving the airflow source around a little, we can watch the system adapt as the direction of airflow moves around. I'm fairly happy with the results of these tests, and this concludes this series. Hopefully you learned a thing or two and maybe even want to try something like this out yourself. Thanks for watching and see ya.